The periodic table has 118 elements. Each element corresponds to a type of atom, defined by the number of protons in the nucleus. For example, hydrogen, which is first on the periodic table, has 1 proton, helium has 2, lithium has 3, and so on. Surprisingly, something as minute as the number of protons in the nucleus can decide how an element behaves in nature and with other elements. Most of these behaviors are rather mute. Gold, number 47, is valuable and shiny. Silicon, 14, is used to make computer chips. Argon gas, 18, is used for welding. However, not every element behaves this way. In fact, very few of these elements can be isolated, that is, separated from other elements that they might be bonded with and be considered safe. Quite a few heavier elements don't even exist in nature, and if ever created in a lab, will only exist for a few fractions of a second before exploding. Some of these elements are downright terrifying. There's no other way to put it. If mentioned, chemists will shudder at the idea of ever encountering these elements in their pure form. Others occur naturally and are quite common, but can still affect the human body in ways that can unexpectedly kill you. In this video, we will explore a list of 5 truly scary elements and the dangerous effects that they have on those that encounter them. Okay, this one's pretty obvious. Uranium is used as a fuel in nuclear reactors due to its highly unstable nature. This means that uranium atoms like to self-destruct and throw their remnants at other nearby materials with high levels of energy. These remnants could hit anything, like other uranium atoms, causing those nuclei to split up as well. This chain reaction, left uncontrolled, would result in an atomic explosion, making the most devastating weapon ever used. If the chain reaction is controlled and used to heat water into steam that turns a turbine, you have a nuclear reactor. Unfortunately, humanity's track record with nuclear reactors isn't an A+. We've had our fair share of nuclear accidents as a society that has resulted in the destruction of entire cities. Uranium isn't only dangerous as a bomb, however. Even after the dust settles from a bomb or an accident, there is still radioactive fallout that can still kill you. Remember how uranium atoms throw off energetic particles? These particles can destroy your cells and DNA, which leads to horrific burns and eventually cancer, the results of which can even appear in your offspring, resulting in birth defects. Uranium is famous for being as powerful as it is terrifying. It goes without saying that if you ever find yourself working with some, please be careful. Mercury is on the periodic table as a transition metal, which is where you find things like nickel, copper, silver, titanium, and other similar metals. So it's odd that mercury is a liquid. In every other way, it's like other metals. It is shiny, it conducts heat and electricity, it is dense, but oddly enough, it is a liquid at room temperature. This is also why it's so dangerous. A liquid of that density being unit weight per unit volume, can easily soak into your skin and enter your bloodstream, poisoning you. So this means that you just must not directly touch it and you'll be fine, right? No, that's not true. Liquids have a property called vapor pressure, which represents how much of it will evaporate into the air given a certain number of conditions, like the container it is in or whatever temperature the air around it is. So if you're not in a well-ventilated area, you will be breathing in mercury vapor whenever you work with this stuff, also poisoning you. Okay, so what if you just don't ever work with mercury and you never see this stuff at all? Would you be safe? No, you wouldn't. Thanks to pre-regulated industry and pollution, there's a large amount of mercury in our ecosystem. If you have too much tuna each week, mercury will build up in your body, poisoning you. It's not all that bad though. If you take precautions when working with mercury and you're careful with how much seafood you eat, you'll be fine. Bromine is number 35 on the periodic table and is grouped up with the halogens, considered to be one of the most reactive groups at the periodic table. Just looking at bromine can tell you that it shouldn't be messed around with. It is a deep red liquid at room temperature and will emit a scary looking yellow vapor into the surrounding air. It's not all evil, however. Bromine has many uses when it is part of other chemical compounds. For example, it's used to sanitize swimming pools, prevent fires, and it even has some uses in agriculture. Bromine is only dangerous when it is isolated into its elemental form. That is when things get scary. Bromine is essentially a vicious poison. It will destroy your eyes, lungs, kidneys, skin, brain, and basically your entire body if you are exposed to a high enough dose for long enough. Bromine is also considered a carcinogen, which is a fancy way of saying that it will give you cancer. Nitrogen is number 7 on the periodic table. One cool thing about nitrogen is that it's everywhere. You are filled with nitrogen at this very moment. The Earth's atmosphere is made up of about 70% nitrogen, and the soil below us is filled with it, as it is needed for plants to grow. You're probably then confused as to why it's on this list. Well, nitrogen has this unique effect on the human body if too much of it is consumed. In fact, there is a name for this exact condition called nitrogen narcosis. This is experienced by scuba divers when they breathe nitrogen at a high partial pressure for too long. It acts as a form of drunkenness when divers will lose their cognitive abilities and judgment. In case you didn't know, the air tanks that scuba divers wear on their backs are not 100% oxygen, as that would be a toxic amount for anybody to breathe. Instead, divers will try to mimic the consistency of the Earth's atmosphere by having a ratio of 70% nitrogen to 30% oxygen. This is a perfect recipe for divers to be exposed to high-pressure nitrogen. Nitrogen narcosis commonly occurs at levels under 100 feet of sea level. This is where the effects become noticeable and requires for the diver to ascend. If they choose not to, the diver could go into a state where he or she is unable to safely operate his or her scuba gear, making a dangerous situation where a simple mistake could lead to death by drowning. Fluorine is recognizable to chemists as a superlative element. Being number 9 on the periodic table, it has the smallest atom in diameter, and it is the most electronegative. This just means that it is incredibly reactive. If an atom can donate its electrons, it can react with fluorine. Fluorine salts are put in the American water supply for its dental benefits. It also has many other uses in the pharmaceutical world and other industrial materials. In the early world of modern chemistry, attempts to isolate fluorine didn't always go as planned. Many early chemists found themselves poisoned by the toxic fumes and suffered damage to their lungs and eyes. Others have had even more unfortunate trials, with some scientists like George Gore nearly blowing himself to bits in his attempt to get elemental fluorine. A successful synthesis hadn't been made until 1886 by French chemist Ferdinand Moissan. Well, this was my list of dangerous elements. If you would like to see more dangerous compounds, or for me to cover any other topics, please leave a comment below. Thanks for watching, and please like and subscribe.